Hello, lovely people. I welcome you once again to Bright and Clara's channel. Thank you all for clicking. This is episode 5 on Project Majesty. Alright, so in your view is a beautiful 3D representation of Project Majesty. This is a big mansion. This is a 6-bedroom house with the basement making it a total of 7 bedrooms. Originally, this was a design. It was just a ground floor because the client had an impression that the land was flat. So everything was based on a flat land. So the design, everything was based on a flat land. Now, upon reaching the site, we noticed that it isn't a flat land. And so it is necessary to go for a basement because the land is very steep, extremely steep. So the basement, and this is what Mr. Hammond did. Mr. Frank Hammond is an electrical engineer, but he has a firm that does architectural drawing, and he spearhead the architectural drawing. And so if you meet Mr. Hammond, you're meeting him for electricals, how do you call it, American 110 220 air conditions installation, okay, cassette recess, split air conditioned, centralized air conditions. And then you are meeting him in terms of structural review, okay, or architectural drawing. You can meet Mr. Hammond in this regard. So he came up with a design beautifully and attached the basement to it, and this is the outcome. So Mr. Hammond is in charge of this project. Okay, so let me pass through with this advert for one of my subscribers. It's a land for sale. It's a registered and a titled land. In fact, he's done the search. There's a search document that proves that this land belongs to him. So kindly contact him. The location is Mataheko Afienya of the Kings Avenue. Okay, and this land is being sold by the owner, not a third party, an agent, or who. No, it is directly from the owner. Okay, so if you're interested, please contact the numbers on your screen. You have to add the country code, okay, which is the +233. You don't have to bring the 0 anymore. If you add the +233, then you add 241516171. Okay, so just take the number, add the code, the country code, which is +233 followed by the number, and the number shouldn't come with the 0 if you are starting with the country code. Okay, unless you are in Ghana, then you don't need a country code. You can just dial the number straight away. Okay, yes, so please do so. Contact him and take it from there. It's a 2-plot. It is not entirely square, but you'll love it. Yes, you will love it. It's in a prime area. There are schools around, beautiful, serene environment. You will like it. Okay, so he's looking for $50,000. Okay, and it's slightly negotiable. So contact him and come and thank me later. The land is good. It's in a good area. No waterlogged area. Nothing. It is perfect. All right. So let's head into Project Majesty. Earlier on, Project Majesty, Mr. Hammond did the pillar castings, and then also some beams on the block work because the height of the block work. So he had to do all of that. And then again, he needed to create an access whereby the beam will hook one side to the other. I'll be showing you that. And here you can see that this is the ground level, and Mr. Hammond will have to do an oversight such that it will raise the structure itself away from the ground. The structure should elevate itself from the ground. And right there he's indicating the hole that have been created in those beams. There's going to be a bar from there that will hook it all the way to the other side when they are coming to do the flow. You understand? During the floor decking, there's going to be a beam holding it from there all the way through, and that is really brilliant. In slope areas of this kind, you don't take chances. The columns are supposed to be very firm because they are the building structures. You understand? Those structures hold the entire building together. If the columns itself are not buried properly, if you don't use the right type of rod, then you are putting yourself in jeopardy. And then also, the client's money is being wasted. And so you need a competent person to be there to ensure that the right type of iron rod is being used, okay? And the structures are being laid accordingly. And also, a topography has been taken to assess the slope of the land in order to design the structure according to the slope. In all these, you have to have in mind that the surrounding areas that are left, okay, there's no cause of erosion. And so the groundworks should be prepared in a way that should there be any rainfall, it will not be coming towards the building. And in this location, that is exactly so. So Mr. Hammond is going to design a good landscape to avoid any erosion. The base of the retaining wall have been cast, and so now the retaining wall reinforcements are standing tall, so it allows the carpenter to do the board settings so they can do the casting of the retaining wall. In the meanwhile, he's placing the footings beam on the block work so as to ensure that there's total stamina for the basement block work due to the height of the block work. And also, it is advisable to do so such that once you pour in the laterite, it will not push the block outwardly. You understand? So all this will be filled with laterite once it have attained its equilibrium or have achieved a top level. You're with me. All these, you have to draw your gradient or your gradient line to ensure, as you've seen right now, you are getting the slope, making sure everything is linear. There's no slope in it. It has to be in equilibrium. Okay, and this is a systematic approach. It is never in a rush. Don't leave it in the hands of the mason to do the decision. No, you need a competent and a qualified structural engineer to be there to supervise when you are building on a slope. All these are called a footings beam. When you lay a block more than 6 cos, 7 cos, and yet you've not achieved your top level, it is advisable to introduce a footings beam. So basically for me, when I lay 6 cos, I don't go to 7 cos. Right after 6 courses of the block, I will introduce my footings beam. And you can see the footings beam have been hooked up to the retainer wall. Okay, yes, so it forms like a closed circuit. You understand? It forms a closed circuit. So the footings beam placed on top. Yes, so just like sandwiching the block in between the footings beam. So the footings beam is in the middle and the block is underneath and then on top of it. So we've sandwiched the footings beam rather. You understand? And you can see the gradient line is drawn again just to ensure all across, to ensure that everything is on its level. You understand? Very, very important. Retainer walls are quite expensive and it is needed and necessary when you're putting up a house on a slope. It helps in protecting the collapse from the upper level towards the down level, okay, or the downward stream from having an effect of the upward stream. Okay, so these retainer walls help to protect the building structures to stand firm. Once you pour in the laterite, there's no crack, okay, there's no vibration, okay, and it provides a better stamina to that of the block. You understand? it provides because of the reinforcement that you have in there. And also, should there be any movement of the earth, you are not affected. You understand? You are not affected. So right after this, a mesh can be introduced on the ground side, because one side will be a floor decking and one side will be on the ground level. Are you with me? So the entire slab can be done as a double mesh. You understand? A double mesh. We usually use 12 mm, okay, for our retainer walls, unless in extreme circumstances where it is a bridge or a bunker or any other walls that perhaps requires higher levels of thickness of iron rods. But ideally, we use 12 mm for that. In other cases, you might introduce 16 mm for certain reasons, for also a good stamina, or if you're looking for a certain type of strength, or you want to introduce the 16 mm as a support, okay, due to the span within the retainer wall. So it means that at intermittent distances, you are introducing a 16 mm reinforcement to serve as a stronghold for the retainer wall. Now the bolts have been removed from the footings beam that have been cast. Okay, so this is a footings beam. In other words, you might even call it lintel when you get to superstructure. Okay, but here we regard this one as footings beam. And so the footings beam done neatly, and then they're going to continue stacking up the blocks until they reach the top level that they are looking for. In the meantime, the carpenters will be ready to prepare the boarding. Now the bays have been cast, and you can see they've supported the retainer reinforcement with wood so that they stay within their grade line. They're not supposed to deviate from the grade line. Are you with me? It has to stay within the grade line. It is very, very important. Else, it makes the carpenter's work extremely difficult. Okay, and when you place the board, the retainer reinforcement should be in between the board, and the gap on the left and the gap on the right should be even, so as to receive the concrete that will support it to hold, firmly. You understand? So all these should be considered during the casting. Usually when we are casting, we shake the iron rod, we shake it just so we want the concrete to go underneath, and then we don't have bubbles and stones gathering somewhere. But it will be advisable to use a vibrator so as not to shift the retainer reinforcement from its grade line, because in the process of shaking it, there's a movement, and once it moves, the concrete takes portion and then it's not able to return to its original position. And so before you realize, the retainer wall is a bit crooked, it's not linear. You understand? So all these should be considered when casting the retainer wall. The view is beautiful, it's majestic. The reason for the name Project Majesty. Okay, if you love this video, give it a thumbs up, subscribe if you've not, and reach out to me if you need my services. My name is Mr. Bright. I am the CEO of B&C Construction. Me to you, shalom, God bless you, bye bye.